The 61850 communications architecture is defined in terms of two buses. These are logical buses. They may in fact share the same media and infrastructure. The station bus is used for high-level communication between IEDs and back to the substation host, which would be the pathway back to the control center. The process bus is used for streaming data between things like from things like current transducers and voltage transducers. These samples can then be shared by the various IEDs in the substation. Three protocols are defined for use on the station bus. The first is a TCP/IP stack containing some application layer things that we'll talk about shortly. The second is the Goose generic object-oriented substation event and generic status substation event, which are link layer protocols used to do things like protection tripping and that sort of thing across the station bus. The third protocol is the simple network time protocol that's a standard IETF. It comes with most of the TCP/IP stacks, which is used to distribute time across the station bus. Three protocols are also defined for use on the process bus. The sampled values protocol is a link layer, specialized link layer protocol for use in distributing the digital samples across the LAN. The Goose GSSE is again the same link layer protocol used on the station bus for substation events, and timesync can also be used on the process bus as well. These definitions all occur in a document 61850 Part 9-2 that defines the use of these. The 61850 documents are organized around a reference model. The reference model includes the application process, which has functions and object models that are defined in terms of a set of abstract communication services. These abstract communication services are intended to isolate the object model definitions from whatever is being used to convey the data underneath the communication scheme. Specific Communication Service Mapping, SCSM, is the term used for the document that describes the mapping of those abstract communication services onto some kind of a communication stack. The first one developed was Part 8.1, which defines the mapping of the abstract services to MMS, Manufacturing Message Specification, which runs over the TCP/IP stack. Other SCSMs are in development, such as the mapping of the services to SOAP and web services. We expect that there will be more. The intent of all of this definition was to be able to do what we call future-proofing. The idea is that in the future there's going to be different communication schemes developed, and we want to be able to preserve the modeling above and just simply map the services onto different communication schemes. The same layered architecture as defined in the reference model is used in the way we build real devices. This diagram shows the triangle server architecture. Device applications, through a set of interface routines, interact with the core 61850 library. This package builds the object models directly from the substation communication language file, which defines the IED capabilities. These models are then mapped onto various services in the protocol stacks. Down the left, we have the manufacturing message specification, which is ISO 9506, which makes use of abstract syntax notation 1, and this RFC 1006, which is the defined way that MMS makes use of TCP/IP services operating over Ethernet. That first leftmost column is the protocol, the SCSM, as defined in Part 8.1 of the document set. The SOAP services are in development. This SCSM will make use of will implement the same services over SOAP and HTTP, the hypertext transfer protocol that's commonly used in web browsers and that sort of thing, which also operates over TCP/IP. Goose services operate directly over the Ethernet interface and don't make use of TCP/IP.